everybody.
Good evening, sir.
I hope everybody can listen me. Can you see the presentation?
Yes, sir.
Yeah, thank you. So let me start today's class. I'm Venkat Subardi, research scholar at the University of Hyderabad. So I'm here to solve some problems from previous year assignments.
Sir, your voice is not audible.
Sir, your voice is distorted, sir. It is not coming clear, sir.
Sir, your voice is not clear, sir. Oh, we are.
Sir, your voice is not audible.
And b equal to 1, 4, 3. So it is asked the optimal least square solution. Can anybody tell how to solve this problem? What is the formula for this? Nobody? Okay, let me tell you. So the given system is in the form Ax equal to b. Of course, A is not a square matrix here. It is of order 3 cross 2. So we can solve this.
Sir, your voice is not clear.
Okay, nobody is saying. I'll solve this. So firstly, let me calculate A transpose into A. This is equal to 1 1. This is A transpose and A is 1 1 2 3 1 2. This result as into A transpose. A transpose is 2 cross 3 matrix, that is 1 2 1 1 3 2. B is 1 4 3. So we have to multiply these three matrices. Of course, matrix multiplication is associative, so we can do multiplication firstly for any two matrices. I'm just doing for the first two matrices. So what we will get is 14 minus 9, this is 5. 28 minus 27, 28 minus 1, Anybody have any doubt in this problem, or is it clear?
Sir, we cannot hear you, sir, clearly. Now it is okay. But there is some distraction in the voice.
Okay, can you hear now?
Now we can hear, sir.
Okay.
But when you were explaining, we couldn't hear you.
Oh, now you can hear me.
Now it is clear, sir.
Okay, thank you. Yeah, I think nobody have any doubt in this problem. In the first problem,
Sir, your voice is not clear. We can't hear. Hello? Not audible properly. Hello?
least square problem. Yes, any doubt?
Sir, again there was problem, sir. Now we are hearing your voice. You just set it right, sir. We cannot hear you.
Okay, you can hear you. Can you hear me now?
Now we can hear, but when you start explaining again, we cannot hear you, sir.
Okay, I think it is working properly.
Sir, not audible. Not, we are not getting what are you saying. You are not audible.
Can you hear me?
Now we can hear you. Once you explain, then there is no clear voice ki we can get it.
Oh, okay, let me remove my earphones. Can you hear me now? I removed my earphones.
We can hear you now.
Okay, thank you. So I'm just substituting that A equal to US V transpose in the above equation. So let's see what we will get. A transpose is VS transpose U transpose. A is nothing but US V transpose. And
Sir,
here,
you show the question again, sir. I mean, explain the question. We couldn't see anything. I mean, we couldn't understand.
okay, sorry for that. So it is given that A is M cross N matrix with real entries, and so we can write A equal to US V transpose, that is singular value decomposition of A. Then for this matrix A, for any lambda greater than 0, it is asked the normal equation of the regularized linear least square system. First of all, do you know what is regularized linear least square system? That is nothing but what I wrote. You just have a look on the question. I'll show you that. So the regularized linear least square system problem is nothing but A transpose into A plus lambda A into X equal to A transpose into B. This is the normal equation we are solving for. So here it is given that A equal to US V transpose. So I'm just substituting the value of A in the above equation. That is nothing but lambda times, I'm just writing I as V into V transpose because we have V is normal. So we can write V into V transpose equal to identity. And here again, instead of A transpose, I'm just writing V S transpose U transpose into B. So if you observe in this equation, we have that here we have V and in the last V transpose. Similarly, here we have V and V transpose. Of course, lambda is there, but lambda is scalar, so we can neglect about that. We can take V as common. S transpose U transpose U S. Of course, U transpose into U is equal to identity, so I'm not writing that. S transpose into S plus lambda into I. On the right side, I'm taking the matrix V transpose as common, so I can write like this. So here we have that V S transpose U transpose into B. Since V is invertible, so we can multiply with V inverse on the left side. Then we get that V and V inverse.
Sir, this is lambda into V, no, sir? The previous step.
Here?
V.
No, we have taken the V outside, right?
Oh, we have taken outside. Okay, it's just lambda.
Yes, lambda I.
I.
Actually,
Okay.
this is a matrix, so we have to write lambda into I. If it is a scalar, then we can write only lambda. But here it is, here you can see that lambda into V transpose, that is equal to one matrix. So we have to write lambda into I. So by this we can write S transpose S plus lambda I into V transpose. This equal to S transpose, sorry, X should be there, no? Here, everywhere X has to be there. S transpose U transpose B. This is the normal equation. That is what it is asked. So let me show you the options. So S transpose into S plus lambda E into V transpose X equal to, we have S transpose U transpose B. The first option is the correct option. Do you have any doubt in this problem?
No, sir.
Okay. So the third problem here it is, consider the following linear system. It is given that Ax equal to B for some matrix A and a vector B. So if we apply Jacobi iteration method to solve this system with initial solution, it is given that initial solution, that is x naught equal to 0. If you are following the class notes, you can understand what is x naught. That is nothing but initial solution. That means we are assuming this as a solution, and we will proceed with this according to that method. We will get some final solution. So what they are asking is then the solution after 3 iterations is. So can anybody tell me that Jacobi iterative method, the equation in this method?
No, we know that.
Yeah. Can you tell me that? Jacobi.
Okay. Using the equation only, coefficient matrix, we'll write the equations, and from that we can write, sir, this is very simple.
Yes.
Jacobi iterative method.
So we can write that method is nothing but x power k plus 1 equal to minus plus u x power k plus where k is equal to the diagonal. Let me write a equal to where a equal to d plus l plus u. The given matrix A can be written as this diagonal matrix from sum of one diagonal matrix and one lower matrix, one upper triangular matrix.
Sir, this minus D inverse L plus U is the iterative matrix, right?
Yes, yes.
P, it is called P.
Yes, this can be written as Px power k plus P. So the question it is asked here is, so it is given that x naught equal to 0. So we have to calculate x1, x2, x3. x1, of course we don't know x1, x2, but it is asked that x3 equal to what? For this we have to calculate x1 and x2 both. Then only we can get x3. Given system. Can you please turn off your mic? I'm getting some noise. Somebody, who is that? Somebody's mic is on. This Pratibha.
Sir, in this question number 4, how we write down, suppose we got the number of iteration, then how we are concluding the matrix P?
Matrix P?
For the Jacobi, that same question number 4, you were telling that the iteration matrix P of the Jacobi scheme, x to the power k plus 1, the linear system of equation we are given.
Yes.
Actually, I am not getting, we are finding the iteration, then we are writing in the matrix form.
Yes.
But my answer, one problem of assignment I was solving, I'm not getting the answer. Can you just give me, or only we have to write down the coefficient matrix in form of DLU, then find out the inverse and do like this?
Yes, we have to write A, the given matrix A as D plus L plus U. Then we have to calculate this equation.
Okay, x to the power k plus 1 minus D inverse.
So let me write the given matrix as D plus L plus U, then you will get some idea.
Sir, to use the Jacobi method, why do we have to find out this iterative matrix? Sir, directly we can use the formula, right? We'll write the system of equations, linear equations. Then we will find out first iteration, second iteration. We can do it, and we can find. Is the iterative matrix required, sir, here?
We don't require that.
No, but in this question they are asking to we have to write down the answer, na?
Only the solution is asked. Solution after 3 iterations.
Yes, yes.
No, no, I'm
They are
So we
asking.
will write the system of equations. From the system of equations, we can find out the first iteration solution, then the
no, no.
solution.
Madam, I am asking for the question number 4. Question number 3 is clear, sir. The
Yes.
third one, the iteration will get the solution. That is clear. I'm
Sir,
asking for
you
the
are
question.
doing, sir, you are doing 3 or 4, sir.
I'm doing 3.
Madam, he is doing 3.
Okay, sorry. 3 is clear, sir. There is no doubt.
Okay. Okay, we will discuss your doubt about fourth problem when we come to fourth question. So you were asking something. For the third problem, it is asked that the solution after 3 iterations. So we have to calculate x1 and x2, x3. Then only we can, by this iteration formula, we cannot get directly x3. We have to calculate x1 and x2 definitely. Is it clear?
Yes, sir. Yes, sir.
Okay. So given it is that a equal to 2, 1, 4. Can anybody remember that problem? 2, 1, 4, that elements 5, 1, minus 1, 1, 3, 7. 1, minus 1. 5, 1, minus 1, 1, 3, 7. Now b equal to 7, I think. 1, 3, 7. 3, 6, minus 3, 6, 7. Yeah. Can you please turn off your mic, that person? So from this we can write a equal to as d plus l plus u. That, let me write that. D is only the diagonal matrix. That means we have to write the only diagonal elements and the rest of the elements as zeros. So this is nothing but 204. Sorry, 200 010 007 plus the lower triangular matrix. That means the elements in the diagonal and the elements in the upper above diagonal, those has to be zeros. So that is nothing but 0 0 0. Here we will get 5 0 minus 1 and 3 0 plus write 0 0 0 here. 1 4 minus 1. Somebody, I'm getting some noise.
In the second matrix, it is 0, sir, not minus 1.
Second matrix. Yeah, thank you.
But lower triangular.
Yes. That you can see, this is the lower triangular matrix.
Yes.
That the elements are in the lower triangular matrix, which is lower. So for this we can see this is the upper triangular matrix. It is not lower. Getting the noise. Can you please turn off your mic? Maggie, can you please turn off your mic? You are here or not there? D plus L plus U. So let me proceed with this problem. So that means we have to calculate x1, x2 and x3, but given that x0 equal to 0 only, so we can firstly, let me calculate that here. Anyway, we have to calculate d inverse b and minus d inverse of L plus U for all iterations. So let me calculate these two matrices firstly, then we can proceed with the iteration equations one by one. So firstly we have to calculate minus d inverse b. So for this, d inverse is nothing but the derivative of the diagonal matrix, that is 1 by, the derivative is 14. So d inverse will get as 700 0 14 0
002.
Yes, of course we have to do transpose. Of course it is diagonal, so we'll get the same matrix. This is nothing but 1 by 2 0 0 0 1 0 0 0 1 by 7. this is D inverse. So D inverse B is 1 by 2 0 0 0 1 0 0 0 1 by 7 into B. B is 3 6 7. So we'll get this matrix as 3 by 2 then 6 then 1. This is D inverse B. Similarly, we'll calculate D inverse into L plus U. So D inverse into L plus U. This is equal to D inverse is 1 by 2 0 0 0 1 0 0 0 1 by 7 into L plus U. That is equal to 0 1 4 5 0 minus 1 1 3 0. By just doing this multiplication, we will get the matrix. So this is equal to 0 1 by 2 1 2. This is equal to 5 0 minus 1. This is equal to 1 by 7 3 by 7 and 0. So now we will substitute the value of x naught in the above equation. That then we will get x1, that is equal to minus of D inverse into L plus U into x naught plus D inverse B. So in this equation it is given that x naught equal to 0. That is the initial solution that you can see in the question. So with the initial solution 0 0 0, that is nothing but x naught. So by just substituting that, we'll get this is anyway 0. So 0 plus D inverse B, that we already calculated, 3 by 2 6 1. 3 by 2 6 1. So this is nothing but x1 is nothing but this one. Similarly, we have to calculate x2 and x3. Actually, this is a lengthy process. We have to calculate this matrix with the D inverse. This is nothing but just calculations. This will get some matrix, some vector. Again for x3 we will get some vector. Can you do these calculations? Time is running out. So
We will do this.
yeah, I'll reveal the answer. You just do the calculations. The answer is B here. That we can just do the calculations and check. So the fourth problem here it is the iteration matrix P of the Gauss-Seidel iteration scheme. It is also similar, but we'll get change the values of P and Q here just a little. So what it is asked is the iteration matrix P. It is asked to calculate the matrix P by Gauss-Seidel iteration. Can anybody tell the equation Gauss-Seidel? What is P and Q here? Yes, can anybody?
Sir, is it same as minus D inverse L plus U?
Gauss-Seidel. Yes, please.
Is it minus D inverse L plus U?
Huh? Plus D inverse P. Is this? Then what is for Jacobi?
Oh, this is Jacobi.
Yes.
Sir, it is minus bracket star D plus L whole inverse.
Yes, that is the one. Minus D plus L. This is D. D plus L whole inverse into U plus D plus L again whole inverse into B. So this can be written as P into, sorry, x power k has to be there. So this is nothing but minus d plus L into inverse into u x power k plus d plus L whole inverse into b. This can be written as x power k plus q. So here it is asked to calculate the matrix P, that is nothing but minus of d plus L whole inverse into u. The given system Ax equal to B, where A equal to some matrix, comma B equal to some vector. So here it is also similar to the problem 3. We have to write A equal to a sum of d plus L plus u, and then we will calculate that d plus L whole inverse into u. So let me write the given matrix. One three minus 1 2 5 3 1 3 minus 1 3 minus 1 2 5 1
4 6
2
1
6 1
what
4 6 1.
4 6 1
4 6 1. Okay. And B, okay, whatever it is we don't need actually. It is asked just to calculate the value of P, so we'll directly proceed with that. Here you can write this as 1 0 0 0 5 0 0 0 1 plus 0 0 0 2 0 0 4 6 0 plus 0 3 minus 1 0 0 1 0 0 0. This is equal to d plus L plus u. For this we have to calculate that minus d plus L whole inverse into u. So d plus L, it is nothing but 1 0 0 2 5 0 4 6 1. We have to calculate its inverse. Its inverse is nothing but d plus L whole inverse. This is equal to 1 divided by determinant A. Determinant A is nothing but 5 here, that you can see because it is a diagonal matrix. I mean lower triangular matrix. So this is nothing but into adjoint A, that we have to calculate. So we'll get 5 and then minus 2 and then 12 minus 20 minus 8. You just check the calculations. I'll do this. This is 0 and then plus minus plus 1, then 6 minus 6, then 0. This is 0 again. This is 5. We have to do this, its transpose. So we'll get that it is equal to 1 by 5, 5 minus 2 minus 8, 0 1 minus 6, 0 0 5. Are the calculations correct? I hope so. You just check this.
Yes,
Okay, thank you.
correct.
So d plus L whole inverse into u, this is equal to minus 1 by 5 times 5 0 0 minus 2 1 0 minus 8 minus 6 5 into u. U is nothing but the upper triangular matrix, that 3 minus 1 1. The non-zero entries 3 minus 1 1 and the rest are zeros. So this multiplication is nothing but 1 by 5 times 0 15. This is again minus 5. This is 0 minus 6. This is 2 plus 1 3, 0 minus 20 plus minus 24 plus 8 minus 6. This is 2. Are the calculations correct? This is nothing but 0 minus 3 1 0 6 by 5 3 by 5 0 24 by 5 and minus 2 by 5. Here we'll get minus, I think. Okay, it is the P matrix. That is what it is asked. P equal to minus D plus L whole inverse into U. So the answer is this one. Let me show you the options. Which option is correct? I think some calculation mistake is there. 0 minus 3 1. Actually the answer is B is correct. Let me check the calculations.
अरे अपना सेशन अटेंड कर रहे हो आज तो पहली बार कर रहा
Sir,
हाँ यार प्रॉब्लम
sir,
Yes.
show the iteration matrix formula, sir, for Gauss Seidel method.
This one.
D plus L whole inverse into U.
Yes.
Then why did you take the transpose, sir?
What?
You took the transpose here.
Here actually for D plus L whole inverse we have, that is formula is 1 inverse equal to 1 by determinant of D plus L into adjoint of D plus L. This, for this adjoint we have to do the transpose, right?
Okay. Oh.
So 500 minus 2 10 minus 8 minus 6.
टू है ना, उसकी जगह -10 चाहिए,
Where?
मल्टीप्लाई किया है ना।
Sorry, I cannot hear. So can anybody can tell me? Your voice is not clear, ma.
सेकेंड लास्ट मैट्रिक्स में 3 पोजीशन एंट्री है ना।
Yes, for this matrix. So minus 6. Yes, I think it is correct.
हाँ, यू है ना सर, यू इन यू मैट्रिक्स 2-3 पोजीशन एंट्रीज 3 सर, नॉट 1।
Oh, 3 minus 1 1. Oh, sorry. Yes. So here it is 3 minus 1 3. So we'll get here it is 3. So it is 3. So it will get changed in the last two elements, these two elements. Minus 2 plus 3, this is equal to 5, and this plus 8 minus 18, this is equal to 10. Yes. So this is equal to 1 and minus 1 and minus 2. Is it correct? Yes, is it correct?
There should be
Here minus 10, so we'll get plus 2. Yes. Yes, it is correct. So the option B is the correct. Is there any doubt in this problem still?
Sir, can you
Just the calculations we have to do.
no doubt sir.
Yes, somebody was asking. Yes, please.
So just you can repeat. Can you repeat?
Sorry, I cannot hear you. Can you speak loudly?
Sir, I'm asking. Can you repeat the concept?
Okay. So it is nothing but
Not the calculation. Just
yes. Yeah, this problem is also similar to the third problem, but in the third problem and in the fourth problem, it is asked, the question it is asked is different. There it is asked, it is given that x power x naught is given, it is asked to calculate x3, that is third iteration. But it is here it is asked that the matrix P, that is iteration matrix. Of course, this is independent of the vector B here. What is the given vector? Yes, your doubt?
Yes, sir. Yes, sir. Okay.
Yeah, 3, 10, 14. The fifth problem, it is the optimal value of relaxation factor W in SOR scheme for the following linear system. I think you have a similar problem in your current assignment also. So let me do this. Can anybody tell me the formula for this? That W optimal is equal to?
Sir, 2 by mu square,
Yes.
1 minus root of 1 minus mu square.
Yes. This is the formula for this, and here mu is spectral radius of P, that is equal to, here P is the iteration matrix in Jacobian method, that is it is nothing but D inverse into L plus U. So here everything is there, we have to just do the calculations. Firstly we have to calculate the matrix P, then we have to calculate the spectral radius, that is nothing but the largest eigenvalue considering within modulus, that is mu is nothing but maximum of mod lambda 1, mod lambda 2, mod lambda 3. For this P we will get this P is nothing but 3 cross 3 matrix, so we will get 3 eigenvalues, lambda 1, lambda 2, lambda 3. Then we have to take mu equal to maximum of this modulus lambda 1, mod lambda 2, mod lambda 3. For this we have to calculate that formula, 2 by mu square into 1 minus square root 1 minus mu square. Everything is there, only calculations we have to do. So let me write the matrix 2, 1, 0, 1, 2, minus 1. Two, 1, 0, 1, 2, minus 1. Zero minus 1, 3, 0 minus 1, 3. 0 minus 3, minus 1, 3. Into x1, x2, x3 is equal to 1, 6, 4. So we have to write this as Ax equal to B, and we have to write A equal to D plus L plus U in that form. Then we have to calculate the matrix P. So A equal to, tell me that diagonal matrix, 2, 0, 0, 0, 2, 0, 0,
0, 0, 3
yes.
plus
The lower matrix,
2, 0, 0, 0, 0, 1, 0, 0,
yes.
0, 0, 0,
0 minus 1, 0.
minus 1, 0.
Yes, upper triangular 0, 0,
0,
0,
0,
0, minus 1.
minus 1, 0, minus 1, 0.
Here 1.
Minus 1.
Is it right? You missed that.
Sir, yes, sir. Yes, sir.
If you observe, the given matrix A is symmetric, so its eigenvalues will be real only. That we will see later. Of course, I'm just informing that there is no use for this problem about this. So the P matrix, it is equal to minus of D inverse into L plus U. We have to calculate the matrix D inverse first. That is nothing but minus D inverse. D inverse is the determinant 1 by determinant of the matrix D, that is nothing but 12 into the matrix is nothing but we'll get 6 0 0 0 6 again 0 0 0 4.
4.
Yes. So into L plus U. L plus U is 0 1 0 1 0 minus 1 0 minus 1 0. Of course we have to do the transpose here for the inverse D inverse, because that matrix is symmetric, we will get the same matrix. So this is nothing but 1 divided by 12 into
Diagonal matrix, if I think if we take just the reciprocal of diagonal element, then that will be inverse, no, sir?
sorry, I could not hear you properly. Some voice is breaking.
Inverse of diagonal element is just the reciprocal of diagonal entries, na?
Yes, yes, the reciprocal with the determinant. Yes, of course. Yes, yes. The reciprocal with the cofactor matrix, cofactor elements. That means here we'll get, if you do that, this is nothing but the inverse is nothing but 1 by 2, 1 divided by 2, and 1 by 3. 0 0 0 0 0. This is nothing but the, yes, the reciprocal of that
Diagonal.
the diagonal elements. Yes. But just for the calculations, I just kept it there, because then it will become in factors. I mean in rationals. It is difficult to calculate, do the multiplication. Finally, we can do multiply with that 1 divided by 12. So this is 0 and then 6. 0 again, 0, sorry, this is 6, 0 minus 6, 0 0, sorry, this, is it correct? 0, very good, 0,
Minus 4.
4, sir. Minus 4.
here minus 4 and then 0.
मेरे साथ ऐसा हुआ है जब भी जिस प्लांट में मैं हूँ.
Sir, how it is -4? It should be -6, na, when we multiply by the second row in third column.
Yes, yes, this is minus 6. And here 0, yes. Is it correct? No? This is finally 0 minus 1 divided by 2, 0, 1 divided by 2, 0, 1 divided by 2. Here it is minus 0, 1 divided by 3, 0. For this we have to calculate the eigenvalues to calculate that mu. So this is nothing but P. So its characteristic, sorry, P only. Characteristic polynomial is characteristic polynomial of P is equal to the determinant of x minus half 0 minus half x half 0 1 divided by 3 x.
Sir, it is minus x, no, sir? A minus lambda I.
Yes, we can do that anyway. We can do that a minus lambda I, a minus xi, or
Then it is minus x, no, sir, here.
these two are, this also a characteristic polynomial. We can
Oh,
do it.
oh, because modulus you are taking.
Yes, not actually modulus. We'll get that only, suppose this will get as a polynomial minus
Equal to 0.
Yes, suppose let me take p of x.
Okay.
We will get simply that minus p of x.
Okay, sir.
We can say both are characteristic polynomial.
Okay.
Just a sign is differ. We can do that anyway. If we can take that minus also, but that will make calculations difficult. That's why. So this will get x into x square minus 1 by 6 plus half times minus 1 by 6. So this will become x cube
Into x. Sir, here x, second term. Minus half into minus 1 by 2 into x.
here.
Minus half into, okay, plus half into
Yes.
minus half into x.
Why? Yes.
Minus x by 2, sir. Okay.
Yeah, okay. Yeah. So this is x minus x by 6 plus we'll get minus x by 4. This is nothing but x cube by 6 minus 20, sorry, x cube only, x cube, and this is 24. We'll get minus 4,
Minus 10x.
10x. This is nothing but 5 by 12. So the eigenvalues are
0 plus or minus square root of 5 by 12.
so 0, yes, 5 by 12 square root, comma minus 5 by minus square root 5 by 12.
So spectral radius is square root of 5 by 12.
Yes, mu, that is equal to spectral radius 5 by 12. So we have to just substitute this in the equation, that W optimal.
Sir, it is square root, no sir? Square root of 5.
Yes. Thank you. This is 2 by mu square into 1 minus square root 1 by 1 minus mu square. So by just substituting this, we'll get 5 divided by 12, 1 minus square root 1 minus 5 divided by 12. So this is equal to 24 by 5, 1 minus 12 by 12 minus 5, that is 7, square root 7 by 5. So we have to just calculate this value of this.
Sir, 7 by 12, sir.
Yes.
Okay.
So according to the given options, let me decide the option, which option. Yeah, if you do that, it is given in the decimal. We have to check that. Can anybody do the calculation and tell me what's the value of this?
Sir, what is the iterative matrix for SOR method, sir?
SOR? No, there is no method like SOR. Only we have 3 methods, right? What is that? Jacobi method, Gauss-Seidel method, and finally we have one more, that
matrix you have taken as per the Gauss-Seidel. For any method we can take it as per the Jacobi also.
No. For this I have considered Jacobi, not Gauss-Seidel.
For this we have to take only Jacobi.
Jacobi. Yes.
Okay.
That is according to the definition.
Okay.
Yeah. Can anybody tell me the value of this?
Sir, there is something called SOR scheme. No, sir. It is given in videos. SOR scheme.
Scheme?
SOR, yeah, SOR method.
Yeah. This is some one topic, not actually method to calculate the solution. This is some other topic. There is no like iterative method. There is no method in this.
Oh. This is also a stationary method, no, sir, to find the solution of linear system.
No, I don't think so.
Oh, okay,
actually,
I'll check.
Okay, 3 methods are there: Jacobi and Gauss-Seidel, and final one is this steepest descent method.
Steepest descent method is a non-stationary method.
Yes.
But under stationary methods, they have discussed 3 types, sir, where omega comes.
Yeah, omega comes in this SOR only. But
SOR only, sir. What is that SOR then, sir?
Yeah, that is what you told me. So abbreviation is there, no? So what is that abbreviation? I forgot. Yeah, you just check the class notes. You will get. I think there is no method. Only 2 methods are there.
I think C is the correct answer for 5, sir.
Okay. So its value is 1.13339. Okay, by rounding to the 4 decimals, we will get that.
Sir, it is successive over relaxation method, sir. It is discussed in videos, sir.
Oh, okay.
Under that also they have given how to find the solution
Okay.
of linear system.
Okay, actually, I'm not following the classes. You might know that.
Okay, sir. Okay.
So this is about 5th problem. I think the same kind of problem is there in your current assignment also. You just do that. So, okay. Is there any doubt still in this problem? Just
No.
calculations are there that we have to do.
Clear, sir.
So this
Sir,
is
sir, excuse me, sir. In assignment, the second question given in the assignment, there is one formula which is asked, but all the options are not correct.
Yes,
It should be lambda by 2, but it is just lambda, sir. There is one. If you want, I can read it out. Huh?
Yeah, no need. I saw that 1 by 2 is missing there.
1 by 2 is missing.
Yes.
Okay.
There is a mistake. Okay.
And assignment 1 also, the 8th question, the solution you have given it correctly, but the answer which is given over there is wrong, sir. Assignment 1, but the one which you have posted is correct.
Okay.
Non-zero rows.
Okay, there might be maybe
form.
Typo will be there.
No, but they have given option wrong, and we lost marks there, sir.
No, we don't lose. They have already given saying that will not be considered for grading.
Yes.
Okay. Oh, it is told, is it?
Yes.
Okay, thank you.
Okay. So the 6th problem, it is the sufficient condition for convergence of the iterative scheme. X power k plus 1 equal to p x power k plus q. Can anybody tell me this? This is a
nor p less than 1.
Yes, has to be less than 1. So this is a direct statement. You can find this why it is in the class notes. That I am skipping this problem. So let me proceed with next problem. So it is given that A equal to some matrix. This is
Bye.
5 cross 6 matrix. So then sparsity of A. Can anybody tell me that formula?
Number of zeros by total number of elements.
Yes.
Number of zero element divided by the total number of elements. 70.
0
divided by 30. 6 5s are 30.
Divided by total number of so 100%. So by just doing this, we will get this is equal to 21. There are 21 zero elements divided by 30 into 100%. This is nothing but 70%. So option C is the correct. So here the 8th problem, here it is the minimum value of the quadratic form. It is given a quadratic form. We have to find the minimal value. If you are following the class notes, I think there is one theorem. This problem is just similar to solving the when we write this. Let me write this x1 x2 x3. This we can write as half times x transpose ax minus x transpose into b. When we write the given quadratic form in this matrix in this form, then finding the minimal value of this quadratic form is similar to solving the matrix, solving the system that ax equal to b. What it is given, what it is meant that the problem here, it is that minimum, it is asked minimum value of this quadratic form. If you find the solution for this ax equal to b, that means if you find x equal to a inverse b, this is the solution actually. If you this finding the minimal value is similar to this calculating x equal to a inverse b. After calculating this x equal to a inverse b, we will get some column matrix, that is x1 x2 x3. By just substituting these values in the given quadratic form, then we will get the minimum value, and this matrix x equal to this x1 x2 x3, at this point only we will get that minimum value. So there is just calculations we have to do. Can you do this? Actually time is over, so I'll explain the remaining two problems.
Sir, but from where we will get the B when we will construct the matrix?
Yes. So you have to write the quadratic form up to here, this x3 square. Up to this we can write as
1,
X transpose X.
5, 2, 3 is 2, 1.
So we can write this as
-1, -1, 2. Got it. -1, -1, 2.
yes.
Hmm.
We'll get half X transpose 10. Yeah, can anybody tell me this? 10, 4, 0, 4, 10, x2, x3. This is 8, 0, 8, and then x3 square. There is 1. Okay. Minus X transpose, that is x1, x2, x3. We have to write into B. B is nothing but 1, 1, -2. Yeah, this is the matrix. This is the quadratic form, half X transpose X minus X transpose B. There is only the calculations we have to do. Can you do this?
Yes, yes, sir.
Yeah. So let me proceed with the 9th problem. So consider the following linear system. It is given a system. So then the initial solution in steepest descent method, for which the system converges to exactly one system converges to the exact solution in just one iteration. That means it is given that we have to get the solution in one iteration only. That means it is given.
Eigenvector we need to find out, sir.
Yes. When the error term that is denoted with E naught or X naught, this we have to get when we take this as one eigenvector of A, then we can get the solution
Exact solution in first iteration only.
Yes, in first iteration. So what we have to calculate here, that we have to calculate that initial solution. That means we have to calculate the X naught. Let me explain it separately. So this is 9th problem. It is given Ax equal to B. The steepest descent method is nothing but we have to take R naught, that equal to B minus Ax naught, and we have to calculate that X naught here. We have to calculate. But it is given that X, when we take R naught equal to one eigenvalue, then we get the first iteration, that is nothing but x1 equal to, what is the formula, x naught plus alpha naught R naught, where alpha naught is equal to the inner product R naught comma R naught divided by inner product of R naught
R naught, A R naught.
Yes. Yes. When we take that B R naught equal to one eigenvalue, then for this vector x1, this is the direct solution, and which we can get within one iteration. But here it is given, we have to calculate that value of x naught. Of course, it is given that only A and B. From this only we have to do the calculations. But if you observe, we can get this simply. So we have to make equal that R naught equal to, take R naught equal to one eigenvector. Suppose it is equal to some ABC, that equal to ABC. This we have to calculate from the given matrix. Then consider this ABC equal to B. B is given minus A is given. For the value x naught, let me take x1, x2, x3. So what we have here is, we have the value of ABC, we have this ABC, and we have the value of B, and we have the value of A also. From this we can get x1, x2, x3 by just simply solving this. But the question here it is, actually this is a 3 cross 3 matrix A. So for this 3 cross 3 matrix, what we have to take the eigenvector. We can get 3 different eigenvectors, but which vector we have to take? For this problem, we can take any eigenvector. Whatever the eigenvector we take, we can get the solution in first iteration only. For this problem, according to the options, just take the eigenvector corresponding to the eigenvalue 5. Take the eigenvector. If you want to check the options, just take the eigenvector corresponding to eigenvalue 5. Of course, there exist 2 more eigenvalues. I think 1 and 2, the remaining 2 eigenvalues. We can take the eigenvector corresponding to any one of those also. We will get another solution. But which one is that solutions are not in the given options. So I'm just giving you a hint which eigenvector you have to take. If such kind of question is given in your problem, then you have to do the 3 calculations. That means you have to consider each eigenvector and you have to do the calculations, and according to that solutions we have to check the options. Is it clear, this problem?
Yes, sir.
So this is about 9th problem. The 10th problem, here it is. If we apply the it is also same. Given Ax equal to b, if we apply steepest descent method with the initial solution, here it is given that x naught equal to 0, then the solution after first iteration. There is only calculations we have to do. So it is given x naught equal to 0, and as
We need to find out R naught and alpha naught.
We have to calculate that b minus ax naught. Of course, this we will get as b only. From this we have to calculate alpha naught, that is equal to inner product of r naught comma r naught divided by inner product of r naught comma
yeah.
This you have to calculate. You will get some factor, I think some scalar. Then what it is asked, the first iteration, that is x1. Sorry, then the solution after, so x1, that you will get as
x naught plus
alpha
naught r naught into alpha naught.
Yes, r naught alpha naught. Of course, x naught equal to 0. So we will get this as some alpha naught into that we have to calculate r naught, that is nothing but b. Here you can check that b is equal to minus 102. The only thing we have to do here is we have to calculate the value of r naught. Okay, let me complete this problem. So we have alpha naught is equal to inner product of r naught comma r naught. R naught is nothing but b. So
r naught transpose r naught.
Yeah. So this will get 1 plus 2, that is 3, divided by inner product of minus 1 comma 0 comma 2 comma we have to do a r naught, that is 3 minus 3 minus 2, that is minus 5, minus 4 minus 4, 1 plus 4, 5. So this is equal to 3 divided by, so what will get, 5 plus 10, 15. So this is equal to 1 by 5. So what is the option? This is the correct option. This is just alpha naught. We have to substitute this in this equation x1. So then we will get this is equal to 1 by 5 times b. Of course, b is there in the problem. So the option A is correct. Is it clear?
Yes, sir. Sir, I'm having doubt in the assignment question number 8. I'm not getting how to approach it. They have given the quadratic form qx is equals to 1 by 2 x transpose ax minus x transpose b.
Okay.
Then any 3 by 3 matrix is given and the last row, last element is lambda. The value of lambda for which qx attain its unique global minimum. So not getting how to approach it because answer may intervals are given in answer.
Actually, for that problem, A has to be symmetric first of all.
A has to be symmetric.
Symmetric and positive. Of course, it is symmetric. It has to be
It is
positive,
symmetric.
positive definite also.
Yes, all eigenvalues are positive, then it is positive definite.
Yes, for which value of lambda all eigenvalues can be positive. Instead of that, we can just check the principal minors. If all
Principal
principal
minus.
minors,
Yes,
yeah,
yes.
Oh, we need to find out the principal minus should be greater than 0.
yes. Actually,
Oh, that is a condition. Okay.
actually the main condition is it has to be positive definite.
Positive definite.
Yeah,
And symmetric.
yeah, instead of checking all eigenvalues, it is just enough to calculate the
Positive
principal
definite.
minors. Yes.
Okay, sir.
So how to get the value of lambda in interval? For every value, every interval we have to check from answer to question.
No. Suppose, let me write this. So it is given that A, B, C, E, F, G, H, I in the last.
Lambda.
Yeah.
Lambda.
Yeah. First, this we have to check it is positive definite or not.
Okay, done.
Positive definite or not.
Hmm.
For this, what we have to check is the only principal minors. That means we have to check the first element, that is A, whether it is greater than 0 or not. You have to check, and then
Yes.
the determinant of the submatrix A, B, E, F.
Sir, we get, sir, lambda greater than 3 by 8.
Yeah. Don't reveal the answer here. Everybody will copy, na?
3 1 lambda.
Yes, this also has to be 0. From the determinant, you will get the value of lambda.
Determinant of A greater than 0, A, B, E, F. If
Yeah. Is it okay?
Okay, sir. Thank you.
Yeah.
Madam, how it is 3 by 8 greater than?
I simplified that.
Yeah,
I just took the determinant. Determinant you should take because that you have
And
to
I took the determinant of A.
Yeah.
Then the minor, any minor, we can check it out.
No. The first two minors are anyway positive. The third minor is the determinant itself.
First. Okay.
So the first A is nothing but 3, I think. So that is greater than 0. The submatrix is 3 1 1 3, I suppose, as I remember. This is already greater than 0.
9 minus 1 8.
Yeah. So for the
Third one determinant.
Yes, that you have to do the calculations. For what value of lambda, you will get that has to be greater than 0.
Okay, sir.
Yeah. Is there any doubts more?
एक minute, sir.
Sir, we will learn everything. Whatever our doubts, we will ask in the last class. There is only one more class remaining.
Yes.
Sir, I just want to know the one concept of minimum norm solution, least square of by taking any linear system of equation. Can you explain it again?
That first problem.
The
optimal least square solution. Is it?
Yes.
Yeah. So it is given that. So it is given that Ax equal to B.
Yes.
Do you agree? Of course, here A is not the square matrix. It is of order 3 cross 2. So we have to make this as square matrix. Instead of just by multiplying with A transpose on both sides, we will get.
Okay. I done the same, but where I'm missing, I have followed this thing.
Yeah. So now we have that A transpose into A is square matrix. So we can do the inverse for this matrix. Just multiplying with the inverse on both sides. A transpose into B. This is the for this value of X, we will get the minimal whatever it is, minimal or least. We will get the least square solution.
Okay, whatever value of X, that is the least square solution.
Yes.
Okay, thank you, sir.
Yeah.
Sir, is there any direct method we can check it out? Ki Gauss-Jacobi for any linear system of equation, Gauss-Jacobi and Gauss-Seidel method are converging or not?
Yeah, for that iteration, we have that iteration matrix now. For two different methods, we have the two different matrices P.
Yes.
For those two matrices, we have to check the that norm P is less than 1 or not. If norm P is less than 1, then we can say it converges.
Norm P less than 1. Achha, we will find out the iterative matrix, then we will find out the norm.
Yes.
If norm is less
If
than
it is
1,
less than 1, then it is convergence.
yes. For two methods, we have
I
two different values of P.
yes. Okay, got it. Thank you.
Sir, the similar way to equivalent to the diagonal dominant, sir. Sir, hello. Sir, we have to check the norm condition also same as diagonally dominant condition.
Diagonal dominant condition. No need of that. No need of that. Only we have to check the value norm P is less than 1 or not.
Okay.
Checking it.
Okay.